In this problem, we're asked to rewrite f of x equals 3x squared minus 6x plus 5 in vertex form, a times x minus h squared plus k, and then we're asked to graph it using properties. So the difference between this and the last video try it exercise that we had is that after we complete the square, instead of using transformations, we're going to use properties, and essentially what that amounts to is we have the vertex in vertex form, and then we plot a couple other points. Typically, that's going to be y-intercept, x-intercepts, if there are any, and if there aren't any x-intercepts, then possibly graphing a couple extra points. So I'll go ahead and label our axes first. Now let's complete the square. So we're given f of x equals 3x squared minus 6x plus 5. Let's separate the x terms, and then there's a common factor with 3 and negative 6 of 3, so let's factor that out. So f of x equals 3 times x squared minus 2x. We still have plus 5. So our b is negative 2. So b squared, or b divided by 2 squared equals negative 2 divided by 2 squared, which equals 1, negative 1 squared, which equals 1. So we're going to be adding 1 inside the parentheses. So f of x equals 3 times x squared minus 2x plus 1. Oh, I said 1 and wrote 5 because I was looking at the 5. So plus 1. We're still adding the 5. And then what we actually did was we added 3 to our equation because 3 times 1 is 3. So we added 3. We want to subtract 3 here. We completed the square inside the parentheses, so that becomes 3 times x minus 1 squared, and then plus 5 minus 3 is plus 2. Now, what does that tell us? Well, what that tells us is several things. First off, we'll graph using its properties. We're going to go ahead and use this space down here to start that. So 3, a equals 3. That means that since a is greater than 0, that means it opens up. And when x equals 1, that's the axis of symmetry. We know that y equals 2. In other words, our vertex is at 1, 2. So let's go ahead and graph that. 1, 1, 2. And we know our axis of symmetry is at 1. X equals 1. So let's go ahead and find the y-intercept. That's when x equals 0. So f of 0, we'll go ahead and use the vertex form, equals 3 times 0 minus 1 is negative 1. Negative 1 squared is 1 plus 2. So that equals 5. That means our y-intercept is at 0, 5. So we'll go ahead and plot that. 1, 2, 3, 4, 5. But because our axis of symmetry is at x equals 1 and we're at 0, 5, that means we're also going to be at 2, 5. Now we should know already, if we checked the discriminant, we would see that it's less than 0. There are no x-intercepts. So we have our basic form here. Let's go ahead and substitute a couple more points. So f of negative 1, well, that would equal 3 times negative 1 minus 1 is negative 2 squared is 4. So 3 times 2 is, or 3 times 4 is 12 plus 2 equals 14. So that's going to be off of our graph. The same thing would apply with if we plotted the point at 3, we would get 14 as well, which is going to be off our graph. So we just know that this is the general shape, and keeping in mind that we want to be at 14 at the next one, it's going to be a little steep. And that gives us the graph for f of x equals 3x squared minus 6x plus 5.